We are here with Hap McSween, the president of GSA. So Hap, your address is called Mapping the Planets, Geology Stakes Its Claim. What is new about this aspect of geology?
Well, obviously we know a whole lot more about the planets. They used to be viewed only from afar, points of light, and spacecraft have basically transformed them from astronomical objects into geological objects. So there's been a significant shift of a lot of scientific real estate into geology from astronomy, but I don't think geologists have truly figured this out yet.
Right, so what has actually changed to make this possible?
It's spacecraft. It's a close look. We have spacecraft that have orbited all of the inner planets and allowed us to map them. And at least in the case of Mars, we have rovers that drive around on the surface and do geology at the scale of a human geologist. So it makes it a lot easier to understand in terms of geologic mapping when you do it at the right scale.
So what are some of the insights that have been learned so far?
The planets are basically operating by many of the same rules that we know and love from studying the Earth, but they are experiments done on a grand scale under different conditions with different starting compositions. So, for example, we have learned that plate tectonics is unique to the Earth. It controls most of the geologic processes that we see on Earth, but we don't have it on other planets. They are one-plate planets, and therefore these bodies lose heat in different ways. The style of volcanism differs. Liquid water on the surface is unique to the Earth, at least at the present time. Mars probably had water on the surface in the distant past. So we're seeing some of the same processes, but when we do, they operate in different ways.
So what does it take to actually study the geology of other planets?
You can do this a number of ways. I work on orbiters, spacecraft that orbit Mars. I'm also working on a spacecraft that orbits asteroids right now. I've worked on Mars rovers, and I do a lot of work with meteorites, which mostly are samples from asteroids, but some of them are Martian samples. The ones I'm particularly interested in are samples that have been knocked off Mars by large impacts. So this gives us a chance to do to these rocks what we do to rocks in the laboratory on Earth. We can treat them the same way.
Interesting. So what's been the importance of all of this in your research of geology?
In part, it is understanding the nature of processes that we study on Earth. Are those endemic to all bodies, or how do they change when you change the conditions? So that's part of it. And we can't run the Earth experiment again under different conditions. We have one grand experiment that nature has given us. But these planets are other experiments run basically in a different laboratory. So that's part of it. The other part is it is a way of motivating the next generation of scientists and engineers. And so I think it's a great motivator for people to get into technical fields.
Well, it sounds fascinating, and I'm sure many people are interested and excited. I am, for sure, to listen to your address. Thanks for being here today.